we have 4 situations. We can have calcium, aluminum, lead, or zinc ion. For me to remember this, I use a mnemonic, which I found to be quite useful. Can all leaders sing? Okay. Calcium, can. Aluminum, all. Lead, leaders. Zinc, sing. Here are the 8 common ions that we normally test for in the identification of cations. And you can see we have the copper, zinc, aluminum, ion 2 and ion 3, calcium, lead, and ammonium ions that we want to test for. So normally, ideally, we make use of sodium hydroxide and ammonium hydroxide to test for all these cations. And then in addition to that, we make use of some confirmatory reagents, and that is what we're going to be looking at systematically as we go over through this video together. So the first step that we need to do is to add drops of sodium hydroxide to the salt solution containing the unknown cations. Okay, so as we had that, we need to observe what are we actually seeing, what are we noticing in the reaction of the sodium hydroxide with the salt solution. Okay, now the first question we need to ask is there a precipitate? And that will warrant us to, okay, if there is no precipitate, okay, we need to now go ahead to heat the solution with a Bunsen burner and test whatever gas is evolved with red litmus paper. And the evolution of pungent gas, which turns red litmus blue and forms white precipitate with the cover of conc hydrochloric acid, confirms the presence of ammonium ion. The pungent gas is choky and it is the ammonia gas. The white precipitate that is formed with the cover of concentrated hydrogen chloride is ammonium chloride, because the ammonia will react with the hydrogen chloride to form ammonium chloride, which is a white precipitate. So this is showing us that whenever there is no precipitate, what we just need to do is to heat the solution, and if a gas that is described like this is evolved, then ammonium ion is present in the solution. Okay. However, if there is a precipitate, we also need to ask some further questions. And the first thing is that, is it colored? Okay. Now, if the precipitate that we're observing is a white precipitate, that is indicating that any one of calcium, aluminum, lead, or zinc ion is present in the salt solution. And the precipitate may be calcium hydroxide, aluminum hydroxide, lead hydroxide, or zinc hydroxide. These are reacting with the sodium hydroxide to form the hydroxide that are listed on the board as shown. So if that's the case, then what we need to know, initially we're adding sodium hydroxide in drops. Now we need to add it in SX. Okay, we need to add more of sodium hydroxide, in short, to make like twice the amount of the salt solution that we are testing for. So after adding sodium hydroxide, we also need to check, is there a precipitate that we are observing? Now, if there is a precipitate, meaning that the precipitate that we observed before is insoluble in the excess of sodium hydroxide, then we are suspecting that calcium ion is present in that particular solution. And we can confirm that by adding dilute hydrogen tetraoxosulfate 6 acid to a portion of the original solution. Okay, we go back to the original solution, we take a portion of it and test with dilute H2SO4. So if we are now observing a white precipitate, which is calcium sulfate, that means that calcium ion is confirmed to be in that salt solution. So now, if there is no precipitate in excess of sodium hydroxide, then we are still left with any of calcium, aluminum, or lead ions that are possibly to be present in the solution. And what we now need to do is we now add aqueous ammonia, that is ammonium hydroxide. We add it in drops. Normally, we will not notice any change, so we keep on adding until we add it in excess to the solution. Now, in adding that, we now need to also observe, is there a precipitate that we can see? If there is no precipitate in the excess of aqueous ammonia, that confirms the presence of zinc ion. Okay, the zinc ion will not react with the ammonium hydroxide in excess, in drops, and even in excess. So that means that zinc ion is present in the salt solution that we are testing for. However, if the precipitate we are coming from initially is insoluble, okay, that means that we either have aluminum ion or lead ion to be present. And for us to distinguish between these two, we need to add potassium iodide solution to a portion of the original solution so that we can just know, okay, is it aluminum or lead that is present in our source solution. Now, if we are adding potassium iodide, we need to observe, is there a precipitate that we are observing? If there is no precipitate with potassium iodide, that means that aluminum ion is present in that source solution. However, if it gives us a yellow precipitate in the solution, that confirms the presence of lead ion. Okay, so now we have looked at the situation in which there is no observable phenomenon that is taking place. We have also looked at the situation in which we have white precipitate taking place. What of the case in which we have a colored precipitate, okay, that is not white? So we need to ask ourselves, which color are we looking at? Which color are we observing? And the first one is that if you have a blue gelatinous precipitate with drops of sodium hydroxide, that is indicating that we have copper ion present in the solution. And what do we do in that particular case to confirm if it is actually copper ion indeed? We now add excess of aqueous ammonium, that's ammonium hydroxide. So if we add that in excess, and what we are seeing is a deep blue solution, that automatically confirms that copper ion is present in the source solution that we are testing for. Okay. However, if the color we are observing is a green precipitate, that means that ion 2 ion is present in the solution. Now, if we leave that particular green precipitate in here and it is turning reddish brown, that means that the ion 2 ion is being oxidized to ion 3 ion. So this is the unique test for ion 2 ion. And for us to confirm, we just need to add potassium ferricyanide solution to this particular source solution that we are testing for. If you notice a dark blue precipitate, that confirms the presence of ion 2 ions. Okay, and then the third case, when we're having colored precipitate in the addition of sodium hydroxide in drops, if we see a reddish brown precipitate, that is telling us that ion 3 ion is present in the solution. And to confirm, we just need to add potassium thiocyanate solution, and an Osborne solution will confirm the presence of ion 3 ions. Now, this is the overview of the test for identifying cations that we can carry out with sodium hydroxide and aqueous ammonia with the confirmatory reagents that we need to test for them. A unique thing that we need to note is that we have three cases. Is either there is no precipitate at all, which is the case in which we are suspecting ammonium ion. And what we need to do is we bring a Bunsen burner, we heat the solution, we test with red litmus paper, okay, and if that is turning blue, we know that that is ammonia gas, which is confirming the presence of ammonium ion. However, if there is a white precipitate, we have four situations. We can have calcium, aluminium, lead, or zinc ion. For me to remember this, I use a mnemonic, which I found to be quite useful. Can all leaders sing? Okay. Calcium can, aluminium all, lead leaders, zinc sing. Now, after suspecting that any of these four cations are present, what I need to now do is to add sodium hydroxide in excess. And the first one that I can actually eliminate is the first one, calcium, because calcium will be insoluble in excess of sodium hydroxide. And for me to just confirm that it is calcium, we just need to add dilute H2SO4. And when it gives us a white precipitate of calcium sulfate, that means that calcium ion is present in the source solution that we are testing for. However, in the case in which there is no precipitate, the precipitate we are coming from initially with drops of sodium hydroxide, if it is soluble in excess of sodium hydroxide, we need to take the test further and we need to add ammonium hydroxide in drops up to excess. And then we need to observe, is there a precipitate? If there is no precipitate, now the last cation from my mnemonic, can all leaders sing? The last cation, zinc, is coming out. It will not give us any precipitate with ammonium hydroxide. So I've eliminated zinc. That is leaving me with only two. That's leaving me with lead and aluminum ions. And for me to just test those ones, I don't need to add potassium iodide. If there's a yellow precipitate, that is for lead. If there's no precipitate, that is for aluminum. So this is a systematic approach to identifying cations. All the other ones, they are unique in colors. Copper is blue, ion 2 is green, ion 3 is reddish brown. And with this, we trust that we'll be able to master the identification of cations and be able to tackle whatever questions in qualitative analysis, in chemistry, on the identification of cations. We trust that you will find this video useful. Don't forget to subscribe to our channel. We have a lot of resources that are constantly being updated for you to build academic excellence in your STEM subject. It's Dave Tooth Academy, and until next time, God bless you.